In this video, we are going to be learning multiplying fractions. So when multiplying fractions, we take our numerators and we multiply them together. So 2 times 5, which is 10. And then we take our denominators and we multiply them together. So 9 times 7 is 63. Our final answer is 10 over 63, or 10/63. The second question we have here, we have 3 times 1, which is 3, and then 5 times 4, which is 20, making our final answer 3 over 20. Oops. And in this last question, we have 3 times 1, which is 3, and 5 times 2, which is 10, making our final answer 3/10. You might notice in questions 1, 2, and 3, I signified we were multiplying in 3 different ways. The first one is the classic X to represent multiplication. The second one is with the dot, and the third one is with the word of. In example 4, we're going to do the same question twice. The first way we're going to do it is the way that we have just been doing it. 3 times 2, which is 6, and then 8 times 5, which is 40. Now remember, our fractions must always be in simplest form. So 6 over 40 can be reduced. We can simplify this by dividing by a number that goes into both of these numbers. So 6 and 40 are both divisible by 2. So I'm going to divide by 2 on both of them. And we get 6 divided by 2 is 3, and 40 divided by 2 is 20. So our final answer there is 3 over 20. The second way we're going to do it is by simplifying before we start, which I want to get into the habit of you doing that the most. So the first thing we do is look in the diagonals. 8 and 2 are diagonal from each other, so I have 8 and 2, and we're going to simplify by finding a number that goes into both of these numbers. So 2 goes into both 2 and 8. So 2 goes into 2 one time, and 2 goes into 8 4 times. When we look on the other diagonal, we have 3 and 5. Nothing goes into both 3 and 5 besides for 1, so those are going to stay the same. And then we're going to multiply straight across. In our numerator, we have 3 times 1, which is 3, and 4 times 5, which is 20, making our final answer 3 over 20, which is the same that we got before. In example 6, we are going to multiply, we have a baby alligator that is 6 yards long, and an adult alligator is 12 times as long as the baby alligator. So we have 5 over 6 times 12. Okay? So whenever we have a whole number, we're going to put the whole number over 1 so that we can make it a fraction. And we're going to look on the diagonals to simplify first. We have 6 and 12, and 6 and 12 are both divisible by 6. 6 goes into 6 one time, and 6 goes into 12 2 times. Then we have 5 times 2, which is 10, and 1 times 1, which is 1. 10 divided by 1 is 10. And since we have units here, since this is a word problem, we have 10 yards. And that is what the adult alligator is, 10 yards. Now let's go into multiplying mixed numbers. When we multiply mixed numbers, we must make this an improper fraction first. So the way we make a mixed number into an improper fraction is we multiply the whole by the denominator, so 2 times 3, and then we add the numerator. So 2 times 3 is 6, plus 2 is 8, and we keep our denominator the same. So let's do that again for this fraction. We have 3 times 4, which is 12, plus 1, which is 13. So we have 13 over our original denominator, which is 4. Then we're going to look on the diagonals. We have 4 and 8 on this diagonal, and 4 and 8 are both divisible by 4. So 4 goes into 4 one time, and 4 goes into 8 2 times. When we look on the other diagonal, we have 3 and 13. And there's no number that goes into 3 and 13, so they're going to just stay the same. 2 times 13 is 26, and 3 times 1 is 3. Now, we don't want to leave our fraction an improper fraction, so we're going to make it back to a mixed number. We need to find out how many full times 3 goes into 26. And I know 3 times 8 is 24. So it goes in 8 full times. And since 3 times 8 is 24, there are 2 left over out of the 3. In example 7, we're going to do the same thing. We have 10 times 4, which is 40, plus 1 is 41. And our denominator stays the same. Then we have 2 times 4, which is 8, plus 3, which is 11, and we keep our denominator the same. So this is the reason I like to simplify first, is because when I go to look to go multiply straight across, I see 4 times 11. And if I can simplify that now, I won't have to do 4 times 11. I'll have to do some smaller numbers. In this case, we might not be able to simplify though. So we have 4 and 11, which nothing goes into both 4 and 11. So let's try the other diagonal. We have 4 and 41, which also nothing goes into both 4 and 41. In this case, we're stuck multiplying 4 times 11. But hopefully, most of the time you'll be able to simplify there. So we can't do 4 times 11 mental math, so we'll have to do a little bit of side work. And I'm going to do the side work over here. We have 1 times 1, which is 1, 1 times 4, which is 4, placeholder, 1 times 1, which is 1, 1 times 4, which is 4. 1, 5, 4. So right where we would have, if we were able to do the mental math, we would put it right here, 4, 5, 1. And then our denominator is 4 times 4, which we could do mental math, 16. Then in order to make this, we don't want to keep this an improper fraction, so in order to make this a mixed number, we need to find out how many times 16 goes into 451. So I'm going to do my long division over here and my side work. We have 451. 16 goes into 45 2 times, and 16 times 2 is 32. With 13 left over, bring down our 1. 16 goes into 131 8 times. 8 times 16 is 128, with 3 left over. So at this point in the last chapter, we were doing decimals. So we would add our decimal point, and bring down our 0, and then divide. But we actually don't need to do that in this case because we are using improper fractions. Or we are using mixed numbers. So what we're going to do is we have our whole right here. So we know that 16 goes into 451 28 times. Here is our remainder, 3. And the 16 is the amount of parts. So there's our final answer. For 8 and 10, we're going to skip, but for number 9, it says check for reasonability. So let's remember what we learned about reasonability. We're going to use our estimation to make sure our answers are about where they should be. So we're going to estimate to the nearest whole number. So for number 6, we have 2 and 2/3. Since 2/3 is more than half, 2 and 2/3 is closer to 3 than it is to 2. And 3 and 1/4, since 1/4 is less than half, 3 and 1/4 is closer to 3 than it is to 4. And I know 3 times 3 is 9. So our estimation is 9, and our exact is 8 and 2/3. So I know those answers are pretty close. So that seems pretty reasonable. Okay. For example 7, I have 10 and 1/4. Since 1/4 is less than half, this one is closer to 10. 2 and 3/4, since 3/4 is more than half, 2 and 3/4 is closer to 3. Then I have 10 times 3, which is 30. So my estimate is 30. And 30 is pretty close to 28 and 3/16. So I know my answer is reasonable.